let us try to understand how to draw the ray diagrams using lenses. First, let us talk about the convex lens. It is a converging lens. So, first you have to draw, the rules are draw the principal axis, which is a straight horizontal line through the lens center. Place the lens in the middle with the two focal points marked on both sides. From the top of the object, draw three key rays. The three are, one is parallel to the principal axis, one is through the lens center, it passes straight without bending, and the other one is right through the focal point. So when it comes through the focal point, it emerges parallel to the principal axis. Then the first one is ray parallel to the principal axis. It refracts through the far focal point. Then the image forms when refracted rays intersect after passing through the lens. When it comes to the concave lens, it is a diverging lens. So the same process, set up the principal axis, mark the focal points, draw the rays from the object's top. Now we have to draw parallel to axis, which diverges as if it is originating from the near focal point. In the case of convex, it is converging, now it is diverging. And a ray through the lens center, it goes straight, undeviated. The diverging rays appear to originate from a virtual image on the object side. You must use a ruler for accuracy, and arrows indicate ray direction. The intersection point of the reflected rays marks the image top. The real images are converging and they are inverted. The virtual images, they diverge and they are upright. So these are the different diagrams. When in this case of this convex lens, when the object is at infinite distance, at far off distance, we are drawing lines like this. One is passing through the optical center, the other one passing through the focus, gets reflected, comes back parallel to the principal axis. The intersection of this is your image. It's an inverted, real diminished image. The image distance is equal to the focus, which is opposite side of the lens, and object lens of a telescope. It is used in this purpose. Then comes the object distance greater than 2f, f and 2f. So you're drawing a line parallel to the axis, getting diverted. Then passing through the center like this. The intersection is your image. So when the object is beyond 2f, the image is between f and 2f. It is a real, inverted and a diminished image. And it is forming on the opposite side of the lens, and it is used in cameras. When it is at the distance 2f, the image is also formed at 2f. It is inverted and a real. Always the real images are inverted. And it is at a distance equal to 2f on the opposite side. And it is usually used in photocopying machines because we want to have same sized image of the object. In such cases this is used. Now within the focal length between f and 2f, what happens is it's beyond 2f. Same rules, line parallel to this passes through the focus. Ray passing through the optic center goes undeviated. The intersection is here. This is where the image is formed. It is on the opposite side, inverted, real and magnified. Since it's a magnified image, it's used in projectors, photograph enlarging. Wherever you want the image to be bigger or larger in size compared to the object, this feature is used. Now, at the focal length, so when you draw these two lines, it goes beyond. So it's upright, virtual, magnified image. Image is at infinite distance. So basically this is used to produce a parallel beam of light. For such cases this is used. Now within the focal length, when you do it, it is causing this image behind the object, on the same side as the object, and it is virtual, magnified image. In this case also it is magnified. So where is it used? Because it's a magnification that is being employed, is used in magnifying glasses. Okay. So this is how we will be drawing these diagrams, the ray diagrams.